Okay, Pre-Calc, we are going to have a lesson now on geometric series. This is our last week of new material. You're going to have 3 lessons this week. Some of them are a little bit long, so I'm going to try to go quickly through them and maybe just give you some answers to some of the examples and not go through every single example. And then the next week, all you have is your study guide and your test. So, geometric series. So is just defined as the sum of a geometric sequence. And remember, a geometric sequence is something that has a common ratio where you're multiplying or dividing by something to get the next term. So the equation for a geometric series is this. Sn equals a1 over 1 minus r to the n. Times 1 minus r to the n over 1 minus r, where n equals the number of terms, a1 is the first term, and r is the common ratio. So let's look at the first examples. Number 1, we have to find r. They're telling us that these are geometric series, so we don't even have to check to see if they are. We know they are for this lesson. We'll have a lesson coming up where they're going to be arithmetic and geometric mixed, and you're going to have to decide first before you move on. But we know these are all geometric. So to find r, we're going to take one term divided by the term before it, and you get 5. You could pick any term you want, any 2 terms, consecutive terms. I picked the first 2. A1 is 2, n is 9, substituting it into the equation up here, and we get this for number 1. Number 2 is a little bit different because r is negative a half. So it's a fraction and it's negative. If you're just going to put this in your calculator, you have to put parentheses around the negative number. In this case, it doesn't matter. It's not because it's to an even power, it's going to turn positive. And then on the bottom, it's 1 minus negative a half, so it's actually 1.5. And if you do all of these calculations, you will get this over here. Okay, let's look at number 3. Number 3, we need to find r. So we're going to say negative 8 over negative 4, and we get 2. And we need to find a1. A1 is negative 4. What else do we need for our equation? We need a1 times 1 minus r to the n. We also need n. This problem right here for number 3, they didn't tell us how many terms that is. So we're going to have to use our geometric sequence equation to find what n is, because we don't know what n is. So for number 3, we have to do 2 steps before we can use this sequence right here. So let's use this, and we're going to say an, which is negative 16384. That's our last term. We don't know what n is, equals the first term times r, which is 2, to the n minus 1. And we're going to solve this for n. So we're going to divide by negative 4, and we'll get 4096 equals 2 to the n minus 1. And we got to solve this somehow. Do you know how to solve this? There's a couple things you can do. You can figure out that this is 2 to the 12th and get the bases to be the same. Or you could take the log of both sides. That's how we have solved exponential equations before. And you would say log base 2 of 4096 equals n minus 1. You would do that round the world thing, and then you could do that on your calculator with log base 2 4096. And let's see, and you get 12. Either one, you get 12. 12 equals n minus 1, so n equals 13. Up here, if you would have known that 4096 is 2 to the 12th, then you would have had this, so you could just say 12 equals n minus 1, so n equals 13. Either way, you can find that n equals 13. You're not going to have very many that you have to do this way. So now we know what n is, and we know A1, and we know R. So we can use this equation to find S13 equals A1 times 1 minus R to the nth over 1 minus R. And this equals negative 32764. All right, these geometric are going to be really big numbers mostly, or really small numbers if R is less than 1. Okay, let's look at the next one, number 4. This is what I'm saying about some of, there's a lot. Number 4, we have to do the same way. We got to find what n is. We have A1 equals 2500 and R equals, oh, look at that, 4/5. Because you're going to take 2000 divided by 2500. Those are going to cancel, and 5 goes into their 4 and 5 goes into their 5. So R is 4/5. We have to find n. So we're going to say 655.36 equals 2500 times 4/5 to the n minus 1. So we're going to divide by 2500, and you get, well, I'm going to do it on my calculator to make sure that I have it correct. We're going to say 655.36 divided by 2500, and we get 0.262144 equals 4/5 to the n minus 1. If I was going to solve this, I'd go ahead and do that log thing, and I'd say log base 4/5 of 0.262144 equals n minus 1. Okay, I would do the round the world and then do that on my calculator. Log of 0.2624 divided by log of 4 divided by 5. And look at that. This right here, if you do this on your calculator, you get 6 equals n minus 1. Well, I don't know why I put it. And n equals 7. And if you do this, you got to get a whole number. N is a counting number, so it has to be a whole number. So now we're going to put those into our equation to find S7, and we're going to have 2500 times 1 minus 4/5 to the 7th over 1 minus 4/5. And we get 9878.56. All right, that's number 5, or number 4. Let's look at number 5. Number 5 is written in summation notation, so it's going to be a little bit easier. We have n equals 1 to 7 of 3 times negative 4 to the n minus 1. So A1 is when n equals 1. So we'll substitute a 1 in for n, and we get 3. R is just this, so that's negative 4, and n is this, so that's 7. So then we can use our equation and say 3 times 1 minus negative 4 to the 7th over 1 minus, whoop, I did that wrong, 1 minus negative 4. And put all that in your calculator, and you should get 9831. And let's look at number 6. Again, summation notation. We've got I equals 1 to 18 of negative 5 times 2 to the, whoops, I put an I, an n, and it should be an I minus 1. All right, A1 equals this, -5. R equals this, 2, and N equals this, 18. So you didn't even need to substitute in I equals 1 because it's right there. And we get S18 equals -5 times 1 minus 2 to the 18th over 1 minus 2. And this is -1,310,715. All right, big numbers. Oh, there's more. Of course there's more. Number 7. A1 is -96. R is 1/2. And N is 9. If you substitute all those into that equation, you should get -1533 over 8, which equals -191.625. I'm not going to write out all of these. You can do it on your calculator if you would like. Number 8, A1 is -64. R is -1/4. And N is 20. Again, putting all those in, you should get -256 over 5 equals -51.2. All right, now let's look at the next two because these are a little bit different because we don't start at 1. We have C equals 2 to 13. 7 times 3 to the C minus 1. So A1 is when C equals 2. We can't use this anymore. We have to actually substitute it in, and we get 21. R is still this. So that's okay. And N is this, 13 minus 2 plus 1, like we did before. 13 minus 2 is 12. 13 minus 2 is 11 plus 1, so N is 12. And then we get 21 times 1 minus 3 to the 12th over 1 minus 3, and you should get this. And for 10, it will be the same. We have, what is it? I can't even see what that is. It X? X equals 5 to the 12th. So we have this. To find A1, we have to substitute in a 5. So we get 1 over 20 times -5 to the 5 minus 1, which is 4. Okay, 5 to the 4th is 125. So you get 125. No, 5 to the 4th is not 125. 5 to the 4th is 625. So we get 625 over 20, which equals 125 over 4. So that's A1. R is easy. That's -5. And N is 12 minus 5 plus 1, or 12 minus 4, which is 8. So then we have S8 equals 125 over 4 times 1 minus -5 to the 8th over 1 minus -5. And that should equal this. Big numbers. All right, let's look at some applications. Applications number 11. The grocery store started raising money for local students in their first month. They raised $4,000 each month after. They raised 1.5% more than the previous month. Find the total money raised in 4 years. So we need to have A1 is 4,000. A2 is, okay, 1.5% is 0.015, but not A2. Why did I write A2? That's R. R is this added on to the one before it, so it has to be 1.015. And then N is 4 years, but we're counting it in months, so it's 48. So we're going to substitute all of those in, and look at that, to the 48th power. And you should get this. Okay, that's how much money they raised in 4 years. Let's look at number 12. So these are the things you're looking for in the problem. Amari invested $12,000 in a retirement plan. So that's probably going to be where we're starting. With an expected annual return of 7%. So just like up there, we have to do 1.07. What is the balance at the beginning of the 30th year? So that's going to be 30. Put that into that equation. You should get this. Look at that. That's a lot of money. But 7% is a big interest. All right, number 13. Carol wants to be a millionaire if she saves 1 cent on the first day, 2 cents on the second day, 4 cents on the third day, and so on. How many days will it take her to save $1 million? All right, this one is a little tricky. So we've got A1 equals 1 cent, and R equals 2, because we're multiplying it by 2 each time. And N is what we don't know. But we know that SN equals 1 million. That's what we're looking for. We haven't really done one like this before, so let's see how we do that. So we're going to substitute in 1 million for SN, and then we're going to have A1 times 1 minus R to the nth over 1 minus R. And we're going to solve this. I think that she did it wrong in her in there. I think that is wrong. Okay, so I'm going to solve it here. Let me make sure I'm doing this right. Because if R is 2, then the bottom here, 1 minus R, should be -1. So this is -1. So I'm going to multiply by -1. So I get this. Did I do too many? 1, 2, 3, 4, 5, 6. And then I'm going to divide by 0.01. And I get 1, 2, 3, 4, 5, 6, 7, 8. Now I have 8 zeros. And I'm going to subtract 1. And divide by, and multiply by positive, so that the 2 is positive 2. And now I can do that round the world thing. So I can say log base 2 of this equals n. And let's see if it works. And you should get 26.58 about, or 27 days. Look at that. Only 27 days to get $1 million, but pretty soon you're going to be saving a lot. All right, let's look at the next part. That was kind of a funny problem. Now we're going to talk about an infinite geometric series. Look at these two charts that you have here. I got to make that better. I won't be able to put that in there. Okay, so the first one we have a half plus a fourth plus an eighth plus a 16th plus dot, dot, dot forever. Okay, if S1 is a half, that would just be one term. S2, if we add the first two together, we get 3/4. If we add the first three together, we get 0.875. If we add the first four, 0.9375 up to 5. We get 0.96875, and up to 6, we get 0.984375. And this is getting closer and closer to if we did an infinitely many, we would get 1. Okay, this is a series that is an infinite series that is approaching a certain number is called convergent. Okay, over here on this side, our series is 1/2 plus 1 plus 2 plus 4 plus 8, dot, 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 off to infinity. Our first one is 0.5. Our second one is 1.5. And then 3.5, 7.5, 15.5, 31.5, and as this is going off to infinity, this is going off to infinity. Okay, so if it's a series that does not have a certain sum, it's called divergent. And what's the difference between these? What does R, but we started with A1 the same. What does R equal here? R equals 1/2. What does R equal over here? R equals 2. And that is the difference between a convergent and divergent. Okay, if the absolute value of R, because we don't care if it's positive or negative, we just need the value. If it's less than 1, like this one right here, then it is convergent. If the absolute value of R is greater than 1, then it's divergent. And if it happens to be convergent, then we have a formula so that you can find the sum. So for a convergent infinite geometric series, the formula is A1 times 1 over 1 minus R. Okay, now think of what the difference is between where you would use this formula and where it is the one that we were just doing with the other problems. The other problems had a finite number that we were adding up. We knew what n was. It was a finite number. We wanted to add up the first 38 terms or the first 3 terms. Here, n is infinity. We're adding them up all the way to infinity. So let's look at these examples. The first thing we're going to do is say whether it's convergent or divergent. And then if it's convergent, we're going to use this to find what it converges to. If it's divergent, then we're done. They're all geometric. We don't have to check to see if they're geometric. So the first thing we have to do is find R. So for number 11, R equals -12 over 2, which is -6. The absolute value of -6 is greater than 1, so it is divergent. And we're done. Number 12, r equals 24 over 72, which is 1/3. So it's convergent, and we have to find it. So we're going to say Sn equals the first term times 1 over 1 minus 1/3. And that equals 24. So isn't that interesting? Look at that number 12. 72, 24, 8, 8/3. If you add all of those up, you are eventually going to get 24. That doesn't seem right to me. Let's see. The 3/2, 72 times 3/2. That's not right. It's 108. So I don't know why it's there, but that is not right. The answer there is 108. It doesn't make sense if you're adding 72 plus 24 plus 8 that you're going to end up with 24. All right, let's look at number 13. That was weird. R equals 90 over -180, which is -1/2. So this is convergent. And we're going to say that it converges to -180 times 1 over 1 minus -1/2. So let's just do this. This will be 1 over 3/2, which is -180 times 2/3, which is -180 times 2 divided by 3 is -120. Okay, that one makes sense because it is negative. Let's look at 14. We've got r equals, ooh, look at this one, 5/4 divided by 1, which is 5/4. That is greater than 1, so this is divergent, and we're done. Okay, number 15. What does r equal here? R equals 3/4. It's right there in the problem, so you don't have to figure it out. And it's convergent because 3/4 is less than 1. So we say Sn equals the first term, which is 224, times 1 over 1 minus 3/4, which is 224 times 1 over 1/4, which is 224 times 4, which is 896. Number 16, r is -0.2, so it's convergent. And RA1 times 1 over 1 minus -0.2, and that one is 37.5. Number 17 is divergent because r is -7/6, which is greater than 1 if you take the absolute value. And number 18 is convergent because r is 1/2. So we're going to say -8/5 times 1 over 1 minus 1/2, which equals -3.2. All right, that is the end of geometric series.